This paper investigates tailoring of embodied agent using large language models. Remarkably, there is little research on personalization and tailoring of embodied agents. In particular, no work addresses tailoring during use. That means without exiting the immersive environments, just through a conversation. There are a variety of new embodied agent platforms that are emerging thanks to generative AI, and some of the works also indicate the importance of personalization. But what is tailoring? What do we mean by tailoring? When a user modifies, adapts, or adjusts the functionality of an agent during the use rather than during development, we talk about tailoring. In this sense, tailoring shapes the agent long-term attributes. Here we make a distinction between a mere and simple command, which might result in an action of the agent, to a directive that changes more longer term the functionality of the agent. And in this paper, we in particular investigate attributes such as the role of the agent, its goal, its personality, or appearance. This brings us to our research question, which is it feasible to support tailoring in conversation of an agent? This translates into investigating the technical feasibility, in particular looking at the latency and also the user experience in terms of what are motivations of users in doing tailoring, in which settings or which use cases, and what would people like to tailor. This is what we like to investigate. To do this, however, we need an agent that has certain capabilities. First, we need to be able to tailor during conversation. That's the main aim of the paper. But at the same time, to be able to converse with the agent in an immersive environment, the agent needs to have visual scene understanding, which we do through the point of view to analyzing the point of view camera, and also providing spatial coordinates of objects and avatars. And also we need to be able to converse with the agent, so we need to have a speech understanding, and that we do through the whisper tiny variant, and to balance accuracy and latency. At the same time, we need to create an embodiment and generate behavior for the agent. This we do through dynamic 3D models for the avatar, using Ready Player Me, and we use facial blended shapes to enable expression, lip syncing, and also we have animations imported from Mixamo for and we also can combine and control such animations. Now we will see a video of the agent, the tailorable agent. Please note that we have cut out the few seconds of waiting time after issuing let's say an utterance, but this is not more than a few seconds to 10 seconds.
Hi, I'm new to this virtual environment and I don't know what to do here. I'm feeling a bit anxious. Can you help me?
Hi Pritom, it's completely normal to feel anxious when you're new to a virtual environment. No worries. Let me guide you through the basics. You can look around, interact with objects, and explore different areas. Would you like me to explain how to navigate or what activities you can try?
Thank you. Can you tell me why there is a mirror there?
The mirror is there to help create a sense of space and brightness in the environment. It reflects light, making the area feel more open and inviting. Plus, it can be a fun way to check your appearance while exploring.
Can you change to a female agent?
I appreciate your request.
Can you tell me what should I do if I feel harassed in this environment?
If you feel harassed in this environment, it's important to prioritize your safety. You should immediately report the incident to the moderators or support team. They are here to help you. Additionally, you can block or mute any user who is making you uncomfortable. Remember, you deserve to feel safe and respected while you interact.
So now that we have seen one of the examples, let me guide you through the tailoring example and how it works under the hood. So after the user says an input like set the agent's role to be a safety guide for a novice user, we pick up the input and then the detector LLM identifies the tailoring intent and the role and goal. Then the role and goal LLM generates role and goal and stores them in a contextual memory. Afterwards, the behavioral engine takes over from the role and goal and starts to understand the scene, the animation, and the response. Using the scene LLM, it generates the scene context from the screenshots provided in the virtual environment, and it generates animation from the spatial data and the scene description processed by the pose and animation LLM. And then it generates response with the speech LLM, which takes into account the user speech as input and generates the response. Afterwards, the agent's behavioral output is generated. The voice of the agent is generated by Azure text-to-speech, which converts SSML to a high-quality speech, and the agent's pose and animation and appearance is generated by its respective LLMs. Here is the architecture of our LLM-based system. Again, we have done some testing of the performance of our system. For that, we have used all the models for OpenAI's GPT-4o Mini with Azure TTS and a server with 8 vCPUs and 32 gigabytes of RAM. We have used 40 interactions. Out of them, 20 was tailoring commands and 20 was non-tailoring commands. Here are the performance. We can see that the average tailoring case latency was 7.3 seconds and the average non-tailoring case latency was 5.2 seconds. And the main bottleneck was the understanding the scene from the scene LLM, where it took on average 3.2 seconds due to interpreting high fidelity scenes. After that, we have done a user study with a 6-week participatory scenario explorations. There was 5 graduate students, each of them consisting of 6 sessions, 1 hour each. In each week, we have focused on a particular theme. In week 1, we have done the training of the system. In week 2, we did brainstorming in the scenario with the users. In week 3, we did some prototyping. In week 4, we did testing of initial scenarios. In week 5, we refined the scenarios, and in week 6, we conducted the final focus group. Out of that, we created the different scenarios. Now we go back to our main question. Is it feasible to support tailoring in conversation of an embodied conversational agent? From our technical feasibility with the user study, we can say it can support tailoring based on role, goal, personality, and appearance. However, there are some drawbacks. The latency was acceptable, but the response was slow, and the reliability of the responses was not that accurate. And from the user's experience side, the users got to explore 2 concrete use cases where the tailoring is useful. In one scenario, the users went on about social anxiety therapy, where the users predicted social interactions to change the agent's appearance, tone, and feedback style. In scenario 2, language learning, The users tailored a virtual tutor and customized the agent's accent, speech pace, and lesson context. There are some drawbacks of challenges with end-user prompts. Thank you for listening.